Good afternoon, everybody. I apologize for not being with you in this interesting Congress session. In this video presentation, I will talk about the increase in the gas hazard at Vulcano in Italy during 2021. As probably all of you already know, the volcanic degassing resumed at Vulcano in late summer 2021, and the degassing crisis caused concerns among civil defense authorities. Current studies agreed that this crisis, which is still ongoing, is established by a renewed degassing magma depth. A study of the gas hazard at Vulcano was performed by this research group. I am Roberto. I work with this colleague at INGV in Palermo. This is a concise outline of this video presentation. I'll start with an overview of the events which occurred at Vulcano during 2021. Then I'll show some features of the diffuse degassing at Vulcano Porto, which is the settled zone of the island. The central part of the presentation focuses on the investigation method and some results. Then I'll give you some conclusion of this work. Well, late in summer 2021, some notable volcanic variations occurred at Vulcano. I listed here some variation in geochemical and geophysical parameters, which can be retrieved from the weekly bulletins of INGV or the Easy Earthquakes catalog. I call your attention on earthquake, increase of local seismicity, phase of tilt increase from September to October, in remarkable gravity signal on November 2021, increase of the output gas temperature from the fumaroles of the crater rim of La Fossa Con since June 2021, which achieved a maximum in September 2021. Increase of SO2 output up to 200 tons per day since September 2021, while average during quiescent degassing is almost 30 tons per day. Magmatic signature of some elements in fumarole gases, and most important, notable increases of CO2 concentration in the fumarole gases. CO2 achieved 28% in September 2021, while average during quiescent degassing is almost 8%. In this scenario, possible phenomena in the short-medium term can be increase of the volcanic degassing, featured by increase of the degassing from fumaroles, increase of the diffuse degassing, increase in the fumarole temperature, increase in the gas output, increase of seismicity, variations in thermal groundwaters, deformation of the volcanic edifice, landslides, onset of volcanic tectonic seismicity, and impulsive and unpredictable explosive phenomena such as phreatic explosions. Let me to move on to show you the experimental method we adopted for investigating the variations of the gas hazard at Vulcano. This study bases on a periodic survey for soil gas investigation, based on an integrated approach of soil CO2 flux measurements and carbon isotope determinations in the soil CO2, and an integrated continuous monitoring of soil CO2 flux and air CO2 concentration at some selected sites near surface manifestation of the volcanic activity, namely at Vasca, steaming ground at Faraglione, fumaroles, and the submarine volcanic degassing on the floor of Baia di Levante. Since 1988, periodic surveys are performed at Vulcano Porto using a monitoring grid over a fixed area for volcanic surveillance purposes. The targeted area extends from north to south, including the inhabited zone of Vulcano Porto. Previous studies have revealed two areas of anomalous soil CO2 emissions at Palizzi and Faraglione. Soils from these zones persistently emit CO2 from volcanic origin. Faraglione is the settled zone of the island of Vulcano, and the exposure to volcanic gases magnifies the volcanic risk from gas hazard in this area. During period of quiescent degassing, the average soil CO2 flux at both areas is one order of magnitude greater than Vulcano Porto area. The output of volcanic CO2 is almost 15%, owing to a small amount of volcanic CO2 is emitted through not anomalous area of Vulcano Porto. The lateral heterogeneities in the diffuse degassing at Vulcano have varied owing to variations of the volcanic activity in 2021. I'll show now the contour plots for variations of soil CO2 flux from September to November 2021. On 20 September, the soil CO2 emissions were a bit higher than usual at Palizzi and Faraglione, while almost near the background through the Vulcano Porto area. A few weeks later, on 10 October, the soil CO2 emission doubled at Palizzi and Faraglione, and new anomalous degassing zones developed at Camping Sicilia and Piano delle Baracche. The soil CO2 emission increased further at the border of La Fossa Con during the following period, and anomalous degassing occurred through the Vulcano Porto at a very high level. Through the same period, notable variations occurred also in the carbon isotope composition of the soil CO2. The isotopic signature of volcanic origin for soil CO2 was evident at Faraglione and Palizzi on September 2021, while results from later surveys show the volcanic signature for carbon in the CO2 which was emitted from all the anomalous degassing zone and through the border of La Fossa Con. Notably, the soil CO2 emitted at Camping Sicilia had the same isotopic signature of the CO2 emitted from the fumaroles at the rim of the La Fossa Con. Therefore, the CO2 from volcanic origin replaced the biologic CO2 in the soil emissions. The integrated surveys of soil CO2 flux and carbon isotope composition enabled both the partitioning of soil CO2 flux between volcanic and biologic origin and estimating outputs of volcanic CO2 from the soil. Based on the analysis of these results and a comparison with previous studies, we noted increases of volcanic CO2 emissions from almost one order of magnitude, while the biologic CO2 was in the range of the seasonal variability at Vulcano Porto. These increases occurred in a few weeks at an unprecedented high rate. Based on our estimation of the volcanic CO2 emitted by soil, the relative proportion of the volcanic emissions from the soils and the gas output from the crater cone, the solubility of CO2 in mafic magmas, and the articulated plumbing system of Vulcano, which consists of several reservoirs connected at a basaltic magma lying at the crust mantle boundary, we infer that instabilities of 0.15 cubic kilometers of magma body at depth can have sustained the volcanic degassing during 2021 at Vulcano. Let me to move on some preliminary results of an integrated monitoring of soil CO2 flux and air CO2 concentration by a network of automated stations, which were designed for gas hazard mitigation at selected point of interest at Vulcano Porto. The monitoring stations were designed and implemented at the INGV laboratories in both the hardware and the software components. Each station implements measurements of soil CO2 flux in accordance with the dynamic concentration method, the air CO2 concentration at two different heights above the ground, and the measurements of some environmental variables which can affect both the soil CO2 emissions and the air CO2 dispersal in the layer of the atmosphere near the ground. A data logger collects signals from a variety of sensors and delivers measurements on the hourly basis using web services on the internet. These are the 4 selected sites for monitoring purposes of the gas hazard at Vulcano Porto. The selection of the suitable sites for deployment of the stations is based on preliminary soil gas surveys for soil CO2 flux measurements in this part of the island, and air CO2 concentration measurements both indoor and outdoor in the anomalous degassing zone of Faraglione. The Carapezza station is representative for the local background of the soil CO2 flux and the air CO2 concentration, owing to its position far from the most notable surface manifestation of the volcanic activity, such as Vasca or the steaming ground of Faraglione, while 3 stations of Porto, Castello and Roya sites are at variable distances from this point of interest. The deployment of this network is suitable for gas hazard monitoring at Vulcano Porto. Most of the data included in the study concern the unrest period, which onset in September 2021. The time series for soil CO2 flux at 4 sites of monitoring show that Porto and Castello, which are the sites nearest Faraglione, the average soil CO2 flux is one order of magnitude greater than soil CO2 flux at both Royas and Carapezza. The soil CO2 flux throughout the period of unrest varied up to 100% at all sites. Notable variations occurred either before or after some volcanic and seismic events which occurred during the time windows of monitoring, such as 3 earthquakes at depth below 12 kilometers and a notable decoloration of seawater owing to an increase in the submarine degassing at Baia di Levante. Time series of the RCO2 concentration show values of the RCO2 were above the background at all sites. RCO2 concentration at Porto and Castello sites were one order of magnitude greater than sites which are far from the Vasca and the steaming ground at Faraglione. At Castello, the RCO2 concentration before the onset of the degassing arrest was lower than 1000 ppm, while during the degassing crisis, often the RCO2 concentration achieved values greater than 3000 ppm by volume. Seldom the RCO2 concentration at Carapezza and Royas achieved the threshold value of 1000 ppm from September 2021 to April 2022, while that threshold value was exceeded at Royas since May 2022. A comparison of the CO2 concentration measurements performed at two different sites from the ground revealed that there are negligible vertical differences in the air CO2 concentration at sites near Faraglione, while air CO2 concentration decreased with the distance from the ground at Carapezza and Royas. The homogeneously high air CO2 concentration at both Castello and Porto sites indicate that gas hazard was persistently at a high near Faraglione, while gas hazard exhibited variations at sites far from the surface manifestation of the volcanic activity. Clustering on datasets has helped in distinguishing subsets which show various correlations between air CO2 concentration and the soil CO2 flux. Results of cluster analysis revealed that at Porto sites, the air CO2 concentration has one cluster for each height of measurements above the ground. At both heights, the slope of the fitting lines revealed that air CO2 concentration is rather independent from the soil CO2 flux. Similar to what shown by Porto Station, air CO2 concentration at Castello sites were rather independent from the soil CO2 flux, suggesting that at sites near Faraglione, the gas hazard is persistently at a high, owing to the soil CO2 flux exceed the threshold of 100 grams per square meter per day. One of two clusters from both stations at Royas and Carapezza show a strong dependence of the air CO2 concentration from the soil CO2 flux. Thus, conditions for a high gas hazard can be established in accordance with increase of the soil CO2 flux, and condition for high gas hazard can be established also at soil CO2 flux values lower than the threshold of 100 grams per square meter per day. Well, I listed here some conclusion of this work. The volcanic degassing reinforces the soil CO2 emission. High diffuse degassing occur at high crustal permeability zones. Anomalous degassing zones have stable positioning through time due to the geologic structure such as fracture and faults. Variations of soil CO2 emission occurred after the onset of the volcanic degassing unrest at Vulcano. Injection of the magmatic gases caused this crisis in 2021. Soil CO2 emission caused gas hazard. High CO2 concentration increases owing to variations in the soil CO2 emission. The gas hazard is persistently at a high near the surface manifestation of the volcanic hydrothermal activity. And an integrated continuous monitoring of soil degassing and air CO2 concentration can help for volcanic risk mitigation. The network of automated stations provided timely updated information by using web service data transmission. Results from data collected in 2021-2022 revealed a notable increase in the gas hazard after the onset of the volcanic degassing crisis. Thank you for your attention. Bye!